did force or centripetal force equals.
So we're going in a circle, so we have to have centripetal force. So we know that's true. That's equal to
Force of weight.
Force of weight pulling down, which is in the direction of centripetal force.
Plus force normal.
Plus force normal. Okay, wait. Force normal would be pushing outwards, right? So that's going to get a minus sign.
Okay.
Fair enough. Okay. Hey, determine the force normal by the road on the car as a 22 meters per second. So now we're going to do that. Agreed?
Yeah, mv squared.
So mv squared over r equals force of weight, which is 7 mg, plus negative force normal, which is what we're solving for. Agreed? Okay, so then the car is what, 980 times 22 squared over the radius, which is 95. That's equal to 980 times 9.8 minus force normal. Agreed?
Yeah.
Yes, because force normal is going to push me out of my circle. Because he made this positive, and he made this positive, that's down normally. We have to make that negative because that's what pushes out of my circle, would it not?
I just switched.
All right. So now, oh, my calculator's losing it. 980. Casio, they're never any good. Delete 980. I can do this. 22 squared divided by 95. Okay, and then that's 4993. This is 9604. So I bring that over.
You know,
Did it wrong?
I got a different answer.
For what?
Me too.
I got 14,596.
For which? This?
For the whole thing, for the force normal. Because aren't you going to subtract that?
I'm going to subtract this, and I get negative 4,611 because they're both positive.
Oh, it's because I made my FW.
Wait, why can't we make the force of weight negative instead?
Okay, so if you do that, then this is negative. We want our force to be downwards, so that's negative. Net force has got to be towards the center, therefore down. And this has got to be positive, which is totally okay. I'm okay with that.
I thought, like, any force pointing towards the center is positive.
That's what I heard.
Okay, so here's where we have a conflict, right? Because any force pointed down is also positive, or also is negative, right?
Oh, okay, yeah.
So which way do you want to do this?
Right.
I thought what he was telling me is that he was going to do what you said, which is forces towards the center are positive. So that's positive. That would be positive. It's pulling me down. Force normal would be negative because it's pushing me up. Or you can do the up down thing, in which case every sign gets flipped. It doesn't matter. It's going to be the same answer either way.
Okay.
Yes, ma'am.
But for like the ones with like the airplane, why is the force centripetal not negative there?
Because what we did is we said the force normal and the force of weight are both pushing me down, and the force centripetal was down, so we were all happy. If you want to be down as negative and up as positive, you would make everything negative, wouldn't you? Right, because negative, I want to go towards the center, so that'd be negative. That would be negative, and that would also be negative.
So when the plane is at the very bottom, wouldn't it be?
At the very bottom, they made this positive because we're pushing up towards the center. We made this positive. This made this. What? No, it was negative. I don't know what we did there, but that was negative, right? Negative. Oh, wait, I'm on the wrong problem. Which problem am I on? Hold on. I'm here. This is the bottom one, right?
Yeah.
So we made the bottom. So force weight was negative, so we made it down. We made the force centripetal upwards positive, and we made this one positive. Force. God, this is so bad. Sorry. We made the. That's saying the wrong problem. We made the extra piece here. Force normal being positive. Up.
Okay.
Okay, sorry, that didn't help. All right, let's try this again.
So the car's being pulled down by force centripetal and force of weight. They're both.
No, wait. Force centripetal is doing nothing. Force centripetal is not a force it takes to go in a circle.
Right.
We need it to be directed in this direction, which is the center of the circle. Now, here we end up with a notation issue. Do we say towards the center is positive, like Mr. Cassini, or do you say towards the center is negative because it's down, like Mr. Donahue wants to suggest?
So is forcing weight always going to be the same sign as forcing capital?
No, because at the bottom, what's going to happen? I need a force that drives me up to towards the center, right? So my force of weight's going to be down, probably negative. My force normal is going to be up. And my force centripetal is going to be positive because I want to go up.
Okay.
Does that make sense?
Yeah.
Yes, sir.
Why wouldn't the force of weight be negative as well at the top?
Okay, so here's the question. Okay, so I'm answering this question for the third time, so I need you to tell me where I'm not making sense. We have two different notations. I keep flipping back and forth because you ask me question, then they ask me that question, then they ask me this question. I don't care which notation, you got to pick one or the other. Do you want to make down negative?
Yeah.
Okay, that's what we'll do for you. So what would we do in your case? You would say centripetal force has to be downwards. So you would say negative mv squared over r. Would you not?
Yeah.
Equals, you would say weight's downwards. Love it. Beautiful.
Yes.
And you would say force normal is upwards now.
Okay.
As long as you're consistent, it doesn't matter. Right? But I don't care which way you go. Right? Both make sense. If you have centripetal force problems, you would start to get to doing like things that make you go to the center or positive, things that make you go out or negative, and that's the way I do problems. But generally speaking, we generally didn't do it that way, right? We said up is positive, down is negative, and that's where we end this problem notation-wise. Is that okay with you? Yeah. Are we good? Front row now?
Yeah.
Okay, so let's do the bottom. Let's do the bottom. Mr. Donahue, walk me through the bottom.
How fast would the car need to go?
No, we gotta do the bottom.
Oh, we did?
What's the force normal on the bottom?
Wait, what?
Is that the question?
No.
No! Oh, we don't have a bottom problem? Okay, no. Okay, how fast do you have to go for the car to go launching into the air? In other words, to go outside of the circle instead of in the circle.
Oh, okay.
Okay? So force centripetal is?
mv squared over r.
And that's going to be negative because you want down to be negative, right?
Yeah.
And then force of weight? Still on me?
Yeah.
Agreed? And then what about force normal?
No.
Why? Why is there no force normal? You're right. Why is there none?
Because it's not on the ground, so it's not.
Yeah, the moment it starts to leave the ground has to push up with how much force? None at all, right? Because you naturally want to follow the circle. And if you go any faster, you're not even going to touch the ground anymore, right?
Yeah.
So that's going to be plus 0. Solve for that.
Okay.
Yes, sir.
So if we're not being
What?
if we're not being pulled towards the center, why are we doing this like force centripetal thing? Or I guess like if we're like because we're still.
We're saying this car is going in a circular path over the top of the hill.
Okay.
That's where he's force centripetal.
But then it goes off the ground, right?
If it leaves the ground, that means what's happening is your force of weight is not enough to meet your force centripetal. So we're finding the velocity exactly where they're balanced.
Okay.
Exactly where you don't even need to be touching the ground, you follow that circle.
Okay.
At least temporarily. Right?
Oh. I'm so confused. That's the mass.
All by ourselves, but even though it's negative, we made it positive. And it's still like, we got the right.
Oh, I am not just like I told you. My oldest daughter to this day will tell anybody if you just got a minus sign, forget it. She still turned stable in physics. She was a government major, and she still uses that rule and likes to say that out loud. Which makes me a bad teacher. Okay. Nope, I got the velocity wrong. Okay, so, well, look, what's the minimum velocity allowed to keep me in a circle? Look familiar? How about 30.5 meters per second or faster the car leaves the ground?
Just like this.
Are we good?
Yeah.
All right, as part of your homework, whatever left time I have, you're going to have to do that last problem and get it wrong so that we can talk about it next time.
What time is it?
It doesn't matter. We're going. We're doing. We're learning.
It's not even.
We're going forward.
It's only 1:06.
Okay, so time flies when you're having fun. So what does it sound like when you say it's only 1:06?
I'm having so much fun.
Okay, that's right. At least you got that figured out. All right. So let's talk labs. We're going to get into anything today.
I did that.
Okay, get out your lab procedure write-up. I told you I wouldn't look at it, so if you have nothing written down, just try to follow along.
Here's the one thing I did. I mean, that's I don't know where I
Did you figure out?
I just took the rest of it.